Hey folks, I'm going to be taking you through the day one phases of matter notes that are in your supplement for the unit 2 notes that you should have received from your teacher. So we're just going to be going through the 3 states of matter, not really plasma, but solid, liquid, and gas. So just have your notes available and ready to write all this stuff down as we go through it. Feel free to pause the video at any point if you need more time. So we're going to start out just talking a little bit about the molecular theory, kinetic molecular theory. So even though atoms are quite small, so small that we can't really see them, you have to know that and have this picture always in your mind that they are constantly moving around. They're not static. They're constantly zooming this way and that way and bumping into each other, bumping into the container or whatever the environment that they're in. Some are moving faster, some are moving slower. They're kind of like, if you can imagine, billiard balls on a table that are constantly just zooming around at any given moment. Some are fast and some are slow, but they're all moving at least a little bit. Now, when we talk about temperature, what we're really talking about is on average how fast those atoms in a substance are moving. And when you touch something and you perceive it as either hot or cold, what you're really perceiving is the movement of molecules in that substance. So the more energy that is contained in the molecules of a substance, the faster those atoms and molecules are going to be moving, and the higher the temperature is going to be perceived by you to be. And of course, the slower they're moving, the colder it's going to be perceived. So this picture just kind of shows you a visual representation, a model of the 3 states of matter that we're going to be talking about. And that we already did actually talk about a bit in the first unit. So again, there's 3 states of matter, and each picture is supposed to represent the same substance, just in a different state. So the first state we'll really define as a solid, and it has both a definite shape and a definite volume. You'll notice in that picture the molecules or the particles are very close together. They're almost touching. So they can have some energy, they can move, they just can't really go anywhere. They can kind of vibrate back and forth and knock into their neighbors a little bit, but they can't slide past each other. And that's really what defines a solid, is it can't flow like a liquid or a gas can. Liquids, on the other hand, do still have a distinct or definite volume, but they don't have a specific shape. The molecule spacing or the particle spacing is still relatively close together, but they are far enough apart and they do have enough energy that they can actually slip and slide past each other very easily. So that is why a liquid can flow generally and a solid cannot. So the joke is, what state of matter would cats be? Well, they can fit into any container, then that makes them a liquid. And that's really not that much of a joke. As an anatomy teacher, I could tell you that the body is about 2/3 water, so most of a cat is liquid anyway. But in any case, the third state of matter is a gas, of course, and that state has no volume and no shape. So it can expand to take up as large a container as possible, or it can be compressed to fit into as tiny of a container as possible. But the spacing, you can see in general, between the particles is very, very far apart relative to their size. And their speed is, compared to the other 2 states of matter, very, very fast. So of the 3 states, gas would be the highest energy in terms of kinetic energy. Now, if we consider the density, think back to density from the first unit being the ratio of mass over volume. If we just compare the 3 pictures of our models of states of matter and try to rank order them by the most dense to the least dense, we would see, just think about that for a second. Pretty quickly you'd answer that the solid is the most dense state of matter, and that's generally true most of the time for most substances. Liquid is in the middle. It's almost as dense as the solid, but looks a little bit more spaced out. And then gas is by far the least dense state of matter. Now, there's one really important exception that you need to know about to this general rule, and that is water, H2O, which, even though it's an exception, it's a very common and important substance on the planet. So why is it different? Well, if we compare these like pictures and models of liquid water molecules and ice, H2O, then you'll see, like in this picture, it's actually, even though it's a liquid, the molecules are pretty compact. You can't really see much space between them, maybe just a little teeny bit. But something happens if you remove energy from liquid water and it converts to solid. The molecules actually arrange themselves a little bit in this pattern where they're a little bit further apart, and they kind of have these little gaps. And that's driven by something called hydrogen bonding that we'll go into much later in the year. But it allows water to stabilize in this shape, which is really less dense. So for water, the order is solid. Water is actually solid. The solid state of H2O is is less dense than liquid H2O. All right, and of course, gas is still going to be the least dense of all. So the order between solids and liquids has been flipped. Why is that important? Well, consider whenever water freezes, it freezes on top first, right? Any ice that forms in a body of water is automatically going to rise or float to the top. And that's pretty important because any body of fresh water, or salt water for that matter, in the wintertime, the whole thing doesn't freeze from top to bottom. You typically just get a layer of ice on the top floating, but the liquid water below can remain liquid, so any aquatic life down there can survive. All right, if water actually became more dense when it froze, then you would get a sheet of water that turns into ice and it would sink. And then you get another sheet that would freeze and sink, and another one until the entire lake or sea or ocean or whatever was just one solid piece of ice, and every fish or any aquatic creature would be frozen and dead. So that property of water is actually pretty critical to its ability to sustain life in cold environments. All right, so next, we're just going to talk a little bit about the transition between the three states of matter. So you'll be looking at the top of the next page and just filling in these arrows. All right, so we'll just define the transition between gas and solid, and these are the terms you probably haven't heard of before, but under certain conditions, certain substances can directly convert between like a solid and a gas. An example would be like dry ice, which is carbon dioxide that's in solid form. All right, when it turns into a gas, it is called sublimation. And then the opposite, if a gas is compressed, then it can actually become a solid without going through the liquid phase, and that is called deposition. The terms that you have heard of course, solid to liquid is going to be melting, liquid back to solid is going to be freezing, and then liquid to gas would be vaporization, and gas back to liquid would be condensation. Now, the important thing to notice is the color coding here, the way it's constructed. All right. Any process where you have to increase temperature, where you have to add heat to the substance to make it undergo that process, that is going to be endothermic. So sublimation, vaporization, and melting, all of those are endothermic processes. And if you think about the difference like in particle movement, remember the particles in solids are moving slow, and liquids they're moving faster. So to transition those particles from slow to fast, you're going to have to add energy to them. And we call that whenever you have to add energy to make something happen, that's endothermic. Now the reverse, okay, if we got liquid, particles are moving kind of faster, and we want to freeze them, we want to convert them into a solid, we're going to have to slow those particles down. So we're going to have to remove energy from those liquid particles to convert them into solid. Whenever we remove energy in a process, That is called exothermic because heat is exiting, heat is leaving that substance as it transitions. All right, so it's real important to understand the difference between all of these exothermic and endothermic processes. I'll make sure in your notes that you color code them in some way so that it does make sense with the definitions. Okay, so these are your 3 endothermic phase changes: melting, vaporization, and sublimation. And in all of those cases, you're going to have, again, energy being added to the system, right? So to get solid to liquid, you have to add heat to it. Of course, you have to add heat to ice to turn it into liquid water. Vaporization, to go from liquid to gas, you're going to have to heat that water on the stove to turn it into steam. And then sublimation, again, that's where you go from solid directly to gas. You're going to have to add heat to that. All right, exothermic is when heat is going to be leaving our substance or our system. So condensation, if we're converting water vapor into liquid H2O, as occurs if you have like a cold glass of ice water and it sweats, right? The water collects on the outside. That's because heat is being removed from the water vapor in the surrounding air, and that water vapor is then condensing on the side of the glass. Freezing, when we go from liquid to solid, you put an ice cube tray in the freezer with liquid water. The freezer is removing heat from that liquid to convert it into a solid, and then deposition is when a gas converts directly to a solid. You have to remove heat from that gas to convert it into solid. And that occurs when frost forms on cold mornings, which I'm sure nobody has ever seen here because it just doesn't get cold. All right, so that is it for the information in the handout. Just make sure that you answer all of the homework questions that are on the adjoining page and submit that assignment to your teacher. And I'll see you next time.